Welcome back to my channel KMA Tech Tips. Today we will start a new subject, namely database management system. As you can see here on the board, the name has been written here, and we will have to go through the caption or name of the subject properly. To do so, we need to fragment it. First of all, we need to understand what is data, then database, after that database management, and lastly database management system. And so, as you know, data is nothing but collection of facts and events of objects, are the objects or the objects what we can see, what we can feel, what we can understand around us. And by that set of features, facts and events, we can easily identify each and every object from other objects very uniquely, very clearly. Now the term database. So let us assume this as a virtual container, logical container of data into which we can store some relevant or useful data, and from which we can retrieve, we can fetch our useful data for some necessary actions, operations or processing. Here in the database management system, this container will ultimately be fragmented into tables, interlinked tables or relations within which our actual data will be stored. Now, whenever you are storing data within a virtual container, within a particular container, then obviously you need a efficient management on it. Otherwise, data insertion and data fetching operation would be very haphazard, and it would be very time seeking, and delayed processing would be there in the scenario. Just imagine, just consider your reading room and consider your table, and if you put your daily commodities, daily items on your let's say table or your bed haphazardly, randomly, your pen is there on the bed, your watch, your mobile, your clothes, your books, your everything what you use day per day basis, if you are keeping those things on your bed and suddenly someone asks you to give a pen, okay, then it may happen that you may need enough or more time to search that particular pen what you are trying to find out right now. As because you have stored, you are keeping your daily commodities, daily items or your necessary components very haphazardly, there is no proper management. Okay, so due to lack of proper management, searching time would be longer, would be much more, and that's why it's not expected in computation. So similarly, whenever you are storing your relevant data within the database, then obviously you must need a proper or efficient management on the data. And once data along with management is there, now we can think of a system. Okay, so overall we can have the idea that it's nothing but the database management system. And if we try to understand the block diagram of it, let us consider that this is data set that you have stored in the database, and this is the software component, this is the software tools or components to manage or to access those data. Now they should be interlinked to each other. Now as a whole, you can think this system as the database management system, DBMS. So you have stored your required data within the data container of the data container part of the database, which is connected to the software components or tools that will actually access, that will actually manage those data according to your necessity whenever required. Now here you can see the term access. Access doesn't always mean that fetching only. Okay, so it's not fetching only. Fetching is one type amongst all the possible types. And just imagine, consider the delete operation. Whenever you are going to delete a particular data from the database, then first of all you need to reach to that particular data. You need to access, you need to identify the data which is going to be deleted. So before deletion, access is there. So in another operation, if you are trying to update a particular data, then also you need to reach to that particular data. After that, you would be able to update it. Otherwise, update operation would be very random, very haphazard, and obviously it's not expected. So similarly, in each and every operation of database which is related to data, there is access. Okay, directly or indirectly, data access is there. So overall, we can manage all of those operations by the term access. Hopefully, the idea of the database management system, or very brief top view of the caption, is clear. But one more thing is there. The term that is mentioned here, data, these data must be interlinked or interconnected or correlated, or you can say interconnected, whatever. And what does it mean by the term interlinked or interconnected? So it's very clear. So just imagine if you are trying to store the data of employees' salary within a particular table or relation, and it's obvious that within that table you would not insert a data which is not relevant to that issue. So we are not inserting any student data into the employee salary table. No, we are not inserting the students details or employee details or company details into the employee salary table or relation. So that is one you can think of, that this is the relevancy of data which is suitable for that particular database. One more issue you can think, just consider your postal address. Just consider your postal address within which your name, your care of, son of, daughter of, wife of, etc. Then your state or district, then state, then let's say country, and so on. Just imagine a friend of you is sending a document by post from outside of India to you. So first of all, amongst all the country names here, we need to select India here. Okay, once India has been selected as the country name, then it's obvious that the state name that we are writing here, West Bengal, it should be within the confined set. If you mention here Sri Lanka, then its state name should be different. The name set would be different. If you write down here, let's say Japan, so all the states of Japan would be there in the set of states. Now the theme is that whatever is the name of the country, based on that, the set of states would be one set, amongst which one particular state name would be here against your state. So similarly, as we have written here India, then and there the set of states of India is going to be ready, okay, from which you have chosen one state name as West Bengal. Now once West Bengal has been finalized here to be the state name, then parallelly a set of district names would be there, from which one name, let's say Birbhum, would be selected. Okay, if you write down here Bihar, Jharkhand, Odisha or some other states, then obviously the same state names would not be here. Okay, so that is the correlation from in between a pair of data. So that is the interrelation, interlinked type of data. Okay, so overall, if now you can define the database management system, DBMS, very briefly, very clearly, that database management system is nothing but a collection of correlated or interlinked data and a software component to manage or access those data collectively, we can term it as a database management system. Very nicely. Now, now from the term DBMS, we need to move to RDBMS. This R stands for relational. Okay, earlier we have seen what is DBMS. Okay, now we will have to understand what is RDBMS. And the term R here, sorry, the letter R here stands for relational. So it's going to be relational database management system. Now, what does it mean? Actually, we are having different kinds of database models. Relational database model is one of them, which is very efficient, very frequently used database model nowadays. All the current and updated and efficient database softwares are based on have been designed based on this relational model. Okay. Now, this is not the necessary and sufficient condition. Except this, one more important issue is there to be considered to be the RDBMS. So, first of all, first criteria would be the database system must be based on a relational model. Second point is there is Dr. EF codes, Dr. EF code, CODD codes, 12 rules. Okay, if a particular DBMS or database is satisfying these two conditions, that in this way that database is based on the relational model and the database is satisfying more than 7 to 8 rules of Dr. Code, then only that database would be termed as the relational database management system or RDBMS. Now let's see. This is 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is the boundary level 7 to 8. That database which can satisfy less than 7 to 8 rules of Dr. Code, those are termed as simple DBMS. And the database system which can satisfy more than 7 to 8 rules of Dr. EF code, those database systems can be termed as RDBMS. Obviously, they must be based on relational model. So these two are the conditions for a DBMS to become a RDBMS. Okay. Now, whenever you are trying to clarify the term, let's repeat it again. What do you mean by RDBMS? Then your answer would be RDBMS is nothing but a database management system which is purely based on a relational model or relational database model, and it can satisfy more than 7 to 8 rules of Dr. Code. But here is one lacuna or leaky point is in our present software market scenario, there is no such RDBMS software which can satisfy all the 12 rules of Dr. Code. Okay, only we can find out up to 11. Okay, 1, 2, 3, 4 in this way up to 11. So even Oracle is not satisfying all the 12 rules, though we know that Oracle is the most efficient database management system and it can't satisfy all the 12 rules. So this is the scenario. So it's our ideal case that the database system must satisfy all the 12 rules, but in reality we don't have in such a database management system which can satisfy all the 12 rules, though it's under research. Okay, in future hopefully some database management system will be discovered which can satisfy all the 12 rules. Okay, now why have we moved to RDBMS from DBMS? So it's obvious that RDBMS is much more better. We will see in much more detail later classes. So, but let us try to understand very briefly. RDBMS is most efficient. Okay, rather we can say more efficient than DBMS, because it requires very less assumptions to store data and to access data for any operational cases or for any operational issues. So that's why RDBMS is much more acceptable in our software market scenario. Okay, because very less assumptions are required. Okay, now from next class onwards, we will see chapter wise or topic wise details of each and every module of database management system. Hopefully, you may be benefited, and that is my gain. If you are benefited at least by 1%, it's my gain. Yeah, I will be happy with that 1%. And if it is more, then my happiness will be more. Okay, it depends on primarily on your fulfillment of your necessity, all other issues. So we'll meet again with the next topic of database management system. Okay, have a nice day. Thank you.